All right, let's get started. First of all, thank you everyone for coming here. This is session 588. My talk today is about debugging connected Windows 8 apps. These apps are, of course, your new Metro-style apps that all of you are hopefully dying to write and deploying on your cool new tablets. I see many of you playing with that, so that's great. My name is Raghu Gada. I'm a dev lead in the core networking team in Windows. I love networking. I've been doing networking for over 10 years in the Windows org. I worked on networking UX. I've worked on networking drivers. I've worked on networking services, Wi-Fi, et cetera, et cetera. So hopefully I'm going to be able to show you a few tools today and talk about some of the common problems that we all run into as we're developing the apps. So let's get started. So a quick agenda slide here. We'll talk about setting the context and why this is interesting. We will then talk about the different types of problems one comes into when debugging your apps. I think there is pretty much, other than the alarm app, I can't think of many apps that are non-connected. So almost everything is connecting to some data source, pulling down some information, etc. So I think this is it's a very pertinent talk for most of the apps that are going to be written. We'll also look at the various tools that are available. Some of these tools are what we ship in Windows. Some of this is the development environment you're going to be using. And of course, there are other tools that many of you are already used to. So we will go over a smattering of those. My talk is going to be very, very demo heavy. So you'll see me switching monitors, and also my demo setup is in a server cage on the expo floor. So I'm going to be using Hyper-V Manager to connect to this. I've set up an isolated network, which has at least 5 VMs working in tandem. So there might be a little bit of delay as I'm switching between them, so please bear with me. So at the end, I want you to leave this session knowing how you can use Windows, tools that Windows provides, as well as Visual Studio. I also want you to leave knowing that, okay, there were these different tools I already used to use, and how can I continue using them with Windows. So let's get started. In the end, it's about making money, I hope, for all of you. And if you want to make lots of money, then you want the App Store to have your app and very high ratings for your app. And for that, you want to develop, you got an idea, you want to develop your idea, you want to code it up, and of course publish. But there's an important step in the middle, and that's debugging. Debugging depending on the coder, you can spend 80% of your time or maybe 20% of your time. It just depends on which end of the spectrum you are. To debug, you need good tools. If you have good tools, then you can obviously debug faster and they'll ship faster. More importantly, you'll be writing robust apps that when you're using the networking APIs, etc., you'll be able to handle various situations. So, well, what is a good connected app? How many of you here have attended Peter Smith's talk earlier yesterday? Anybody? It's at the end. I don't remember the number myself, but it was about networking considerations. If you look it up in your on your slate, you'll see on your tablet, you'll see the build app. You can pull it up, Peter Smith, and then you can see the talk that he gave. So this is a one-slide description of what that talk is, and so I'm just summarizing here for you what it means to have a good connected app. The first point here is really about you using the new APIs that we've provided in Windows 8. And the fact is, if you went to Dave Thaler's talk earlier today or to Peter Smith's talk, you would have seen that we've done a lot of work to simplify all the heavy lifting. For example, you had a TCP socket, and then you wanted to make that an SSL socket, right? So previously, you'd have to write, I was told, 20 pages, or you read a whole bunch of manuals and then write a whole bunch of code which again you'd have to debug and stabilize. So some of the APIs are like single lines, or even not a single line, it's like a single element in the line. So we have a lot of rich functionality. So it's about using the right set of APIs, reading the documentation, and using the right set of APIs. And thus, you have a smaller amount of code to write. In the end, it's going to turn out a good user experience because we will be doing the heavy lifting for you. And this is because Windows is not. Windows has to evolve with time. Over 15 years ago, we didn't have multi-homing. We didn't connect to different networks. We didn't have to switch. The event-driven model was different. So for all these reasons, we have new APIs. Here's my second point. We're encouraging all of you to be aware of the fact that a good percentage of the devices, I don't know if it's 15%, 20%, 25%, it's going to continue increasing. The devices that use mobile broadband connectivity. So that's 3G, 4G, these kind of technologies. And there's more stuff coming down the pipe like LTE, et cetera. So we want you to eliminate bill shock. So previously, I've seen all kinds of news articles. Someone went to South America, and they Pixar, I think it was some Pixar movie, or WALL-E. Someone was downloading the movie, and it happened to go over a 3G connection, and the bill ended up to be something like $64,000. So we want you to eliminate that, hopefully using the right APIs, and at least in that person's case, he got a really good deal because they shaved off, I think about $50,000 it was, but he still had to pay something like $15,000. So we want you to not have that sticker shock. And the final point here is we want to raise the confidence when someone is using your app. We want them to feel safe. And I'll come to this concept later, which is the concept of using capabilities that are provided by the system and what it means to use networking capabilities. So I have some slides for that. All right. So we're going to talk about networking problems. And there are various ways of trying to slice and dice this. My classification is pretty simple. On one side, I have app bugs, and one side I have network problems. So app bugs are, you're sitting at your desk and you're coding up against the local server that's on your corporate LAN, and you're making sure that DNS issues are taken care of. You're making sure that, I talked about capabilities in just a little while ago, you're taking care of that. So all the things that you would normally expect sitting on your desk, coding your app up, you're taking care of those. So those are the set of issues that you need to handle. One last one I mentioned on the first column is like the incorrect use of completion handlers in UI threads. We are all aware of apps, including Microsoft apps, that have the spinning donut, or in the new case, there might be dots going across the screen. We don't want people to have that, or dots going in a circle. We don't want people to have that. We don't want you to, we want to make sure that you're aware of these issues and fix those issues. Well, what does the second column mean? The second column is really about you published your app in the App Store, and people have started downloading it. Now the environment in which they're using the apps is obviously different than the environment in which you're using the apps. Maybe they have a different DNS server. Maybe because you wrote such a compelling app, people started downloading it in the tens of thousands, and you're earning lots of money. But your server is under load. Well, that's going to change because that's not the same problem as when you were initially developing the app. So your app, in the end, has to be robust to these kind of issues. And so that's really connection timeouts or resets and differences in topologies, like I was saying, what if I'm going over mobile broadband? What if I'm going over wired Wi-Fi, different Wi-Fi networks? So that's a set of classification of the problems, and we'll look at most of these. Here's a set of tools I'll be using to demonstrate some of these problems. The first one is, of course, Visual Studio. This is installed on your Samsung Developer Preview machine. Then the second tool I'll be using is CheckNet Isolation. This is a power tool we're shipping with Windows. So again, it's available on your PC. The third tool is Fiddler. which is used for debugging HTTP apps. The fourth one is ETW, Event Tracing for Windows. It's been there in Windows for some time, and I'll show you how you can use it, and how you can use it to even see what the system is doing. So there's a lot of information there. And finally, it's my personal favorite. When I joined Microsoft a long time ago, is Netmon. This is how you can get to the bare metal, capture all the packets that are going between your machine and other machines, as well as, if it's in promiscuous mode, everything else that's on the network. So we'll take a quick look at all of these tools. So let's start off with the first one, which is Visual Studio. Visual Studio, as you know, has, by now you've attended a bunch of sessions, and you've seen that Visual Studio is very deeply integrated with a whole set of APIs, and networking is no exception. We have APIs that, for example, are returning rich error codes. You had to go through multiple steps before to find out, well, what is this hex number or decimal number minus something something? What does it mean? Well, we'll see an example of that. We'll also see IntelliSense, right? IntelliSense has always been very, very powerful. We'll see how networking is providing information to Visual Studio and how that's getting displayed. So with that, let's start with a set of demos. I'm actually going to be doing 2 demos back to back here. So the first one is we're going to be debugging DNS errors, and the second one is about finding capability problems. So let's get started. Okay. Okay, so here's my Hyper-V manager. It has a number of VMs running, and I have 2 VMs that I have created over here. Okay. So what I'm going to demonstrate to you is us using the new Windows Runtime Sockets API. There's the Stream Socket and there's the Stream Socket Listener. The smaller one over here is going to act as the Stream Socket server. So this is an SDK sample. It's available for you. You can play around with it. It's exact same code that's running on both the VMs over here. So I'm going to ask this Stream Socket. Well, let me make sure that I've closed all sockets. And I'll start the create Stream Socket Listener. And as you can see from the green text over here, it's created the listener, so we should be in listen mode. Now, on this side, so let me minimize this. On this side, I have what's going to act as the client. So we're going to do step 2 over here, which is connect to listener. And in this case, I'm going to give him the host name, which is so. I hit connect now, and it's going to the service name, which is the port number. This is the default port number, so I'm not going to change it. I'm going to hit connect now. So what's happening is the new connect async API is being called, and if you attended Dave Taylor's talk previously, you will know that the connect async API has a .then, which is an error, and it takes a success and a failure. And I set 2 breakpoints, and as you can see on the screen, we've hit one of the first breakpoints, which is the on connect error. And in this case, when I hover over here, I hope you can see this, is that we have rich error information. So previously, what would happen in Win7, for example, is that we would be providing you this number. You take this number, stick it into your favorite search engine, bing.com for me, and then you'd put this number in, and hopefully it'd give you a MSDN link, and then you'd click on that and then get the information. Well, in this case, we've short-circuited all that, and all you need to see is the description text here, and it says DNS server failure. So let's find out what actually happened here. I'm going to hit F5, go back, and what's happened here is, if you notice, that the host name was actually VM588B. So I did a typo, and so I'm going to fix that. And this time, I'm going to hit connect, and if it connects, we'll hit the other breakpoint I've connected. As you can see, it hit on client accept, and so that was a successful error. So this was a quick example of the rich information in error reporting that we're doing. And in this case, we found out how it was a DNS issue, and we were able to fix it by taking care of the typo that I, obviously intentionally created. Okay, so that was our first demo. Our second demo is about finding capability problems. So capabilities are, there's a number of capabilities that Windows now describes, allows an app to describe, and you elect as a developer saying that I want to use A, B, C, D, I don't want to use EF, I want G and H, et cetera, et cetera. So for example, location or proximity, et cetera, these are capabilities, and we'll take a look at that. So I'm going to stick with the same sample, and hit F5 again. And this time, let's assume that VM588A, this app is going to do some sort of peer-to-peer stuff. So in this case, we want it to do to also act as a server, and so we're going to make it listen. Let's see what happens. So I'll close all sockets, start stream socket listener, create stream socket listener. What you saw just now is the fact that Visual Studio is showing us a WinRT exception. And in this case, the WinRT exception is saying networking E missing capability. Visual Studio has determined that, hey, you're trying to do something, but this was something that you're not supposed to be doing. So it threw an exception. So let's break in. And you can see over here, I'll scroll. You can see that I was trying to do the stream socket listener over here, and the helpful arrow here is saying that, well, this is where the exception happened, and please fix it. So here is where I'm going to do my IntelliSense demo. I'm going to take care of that dot again. And as you can see, a whole bunch of options are listed. And when I hover on it, you'll see that there's something that's describing the API and also says that here's the associated capabilities. And in this case, it's saying that you can either put internet client server or private network client server. The server part means this app can do the listen operation. So where do I go and see these capabilities? Well, you open up your manifest, Apex manifest. And over here, you can see some helpful tabs. And in this particular case, you'll go to the capabilities section. And yes, the private one corresponded to homework networking. It wasn't checked. The internet client server was also unchecked. And so what Visual Studio is saying is that you need to do either of those. So I'm going to uncheck this one. I'm going to recheck this one. I'm going to rebuild my application. We'll do a quick rebuild. Done. Let's deploy it. Done. And let's restart. So at this point, I'm going to go through the same steps, which was start stream socket listener and hit create. Last time we had the exception. Let's see what happens this time. This time, the app says, OK, I was able to create the stream socket listener appropriately. There was no problem. You already pre-declared this capability, and you were thus able to do that privileged operation. OK, so let's switch back to the next tool is called CheckNet isolation. And just a brief description of this. It's provided in Windows 8, and it helps you determine the exact capabilities you required. Visual Studio did a great job saying you're missing something, but it didn't quite tell us like which one you need. So we've written a tool that will help you to do exactly that. The advantage also of using just the required set of capabilities is that it's a matter of least privilege. It's just a principle. So use the ones that you need, and these are going to be displayed in the App Store, so whatever verification, et cetera, that needs to be done could be done. And it increases the confidence. The second point here is really important. Previously, if I did a networking app and I wanted to make it work, especially if it was doing something like a listen, I'd have to test it against the Windows firewall. Then I'd install the latest version of, let's say, McAfee. I'd try it against that. I'd make sure it's working against that. Then I would go and look at Symantec's firewall. I'd install that. I'd test it against that. So there's all this process of like working with different host firewalls and then making sure that your app is working. But if you use the capabilities, simple checkbox for you to do in the Apex manifest, and bam, Windows will do the heavy lifting of making sure that you're working hand in hand with all the appropriate firewalls and that it's actually going to work. So there's no need to open individual firewall rules. You don't have to do any of that coding. Your user won't see a pop-up from whichever firewall that they have installed. So these are all the advantages of doing that. So let's take a look at how you use checknet isolation. I'm going to switch back. All right. So this time, I'm going to use a different app, and let's close this guy and open up a different project. So this is another sample app. It's called My News. So this is supposed to represent some sort of a newsreader app, and in this case, I use this newsreader app to get my latest sports news because it's so cool. And so let's take a look at how the app is going to work. So I'm going to hit F5. And the app is running, but it's pretty much a big blank screen, other than its title at the top. So it's not working, trust me on that. It's trying to get to this news site, and for some reason it's erroring out. Let me just check to make sure that it is indeed an issue. Now I've bookmarked the same website that it's going to. I'm going to click IE because I love this so much, this particular site, so I have it bookmarked. And it's got, in this case, some guys cheering about winning the FIFA U17 World Cup. Anyone know whose Independence Day it is today? Mexico, that's right. And that's why we have our friends from Mexico, displayed over here. So coming back to the app itself, it should have gone to this website, but it wasn't. So let's go back and debug what's going to happen. So let's use the tool called checknet isolation, and I'm going to use the where command to show you. So it is already in system 32, so it's available for you in your path. So let's now do checknet isolation. And if I do a minus question mark, there's a bunch of help. And in this case, I want to debug. So I'm going to do debug, if I can type properly. And what it needs is something called a package family name. Let me show you where you can find that. If you go to the packaging section of your Apex manifest and scroll down below the publisher display name, you'll see this family name. It's something that's generated by us. And so in this case, it's unique. And I'm going to take that and tell that to the checknet isolation tool. And I'm going to say OK. So what the tool is now doing is it's in a repro capture mode. So because we want to debug whatever app that you're doing, we're going to capture the network traffic as it's going back and forth, and we'll try and suggest what might be going wrong. So let's start the app again. I'm starting the app again. I should expect to see the same blank screen because we didn't fix anything. But as far as the tool is concerned, we did a repro. So let's go back to the tool now and hit Control-C. And now we have a summary report. What the tool is really saying is that, hey, there were two things. One is the fact that based on the traffic that you're doing, it looks like you're missing this internet client capability. So you might want to add that. And the second thing is the fact that the private network client server is not used, but it's declared. So let's verify that the tool is indeed saying the right thing. So I switch over to the package to the capabilities tab, and lo and behold, yes, the homework, which is the private one, is checked, and it's saying you don't really need this. I'm going to uncheck that, and I'm going to turn on the internet client capability. Again, this is what I was saying earlier. Try and use the ones only that you need. So now let's go through the process of rebuilding it. Build solution, yes. Okay. Rebuild. Oh, didn't mean to do that. Deploy. And F5. And yay, my Metro style app is now up and running, and I can see the Mexican team. Congrats to that team, and I'm happy. So a quick recap. We looked at the CheckNet isolation tool. It helps you point out exactly what are the capabilities you need and tells you if you don't need them, please don't declare it. So that's how that works. Okay. What's next? Okay, how many of you, quick show of hands, have written apps that do HTTP back and forth traffic? Okay, looks like at least more than 2/3 of you. And how many of you know the tool called Fiddler? All right, that's great. So yeah, Fiddler is a very popular tool. And for those of you who don't know what Fiddler is, it's used for debugging all kinds of HTTP problems. We're also going to see how to use Fiddler, because it's the tool that you already are used to. Fiddler, by the way, was written by a person called Eric Lawrence. He might be actually here at Anaheim, and so if you see him, you can thank him if you want. There's a lot of information here, which is why you use Fiddler. There's back and forth exchanges with whatever web server you're doing, so you trap all that, and you're able to determine. So let's take a look at how you would use Fiddler. So I'm going to switch back. All right, so just to keep things interesting, I'm going to start yet another sample. This is my third sample. Open project. And this is the background transfer download sample. How many of you have attended a session which talks about background transfer APIs? Okay, at least one hand. So please take a look at the sample slide at least. Background transfer API is a quick overview is that it allows you to, in the new process lifetime management, we suspend apps. If it's not in the foreground, it goes in the background, we suspend the app. So background transfer API allows you to actually ask the OS to go and do this download for you. And this is going to help you whether you're in the foreground or you might get flipped anytime to the background. So this is a great API to use, and it takes different types of URIs. I'm not going to go into the exact API description, but here's a sample. Again, it's an SDK sample. Let me hit F5. So I'm going to start the download. As you can see, it's going to this particular URI over here. I'll hit cancel. And since it's, I can also see that there's a bunch of, seems like HTTP traffic. And if you go back to the sample, let's go to program.js. Now, let me enlarge the font so you can see it easily. The only thing I changed in this sample is the resource that we're going to. So HTTP hrweb carp.contoso.com is one of those VM servers I told you about. And it's trying to download this PNG image from there. And in this case, the app was showing you that it tried to do it, but it didn't succeed. So I use the tool I know, and that's Fiddler over here. And I've already set it up. I'll come back to what the setup steps are. I'm going to turn it on, and let's start the tool up again. At this point, I already showed you it's hard-coded. I'll do the start download again, and there's a bunch of back and forth. I'll cancel. Let's go back to the tool in Fiddler and see what it says. Okay, so in Fiddler's, what Fiddler has caught is the fact that there's a bunch of 401 errors. So for those of you who know, it's the authentication, the server is requesting authentication, and Fiddler has caught that. And of course, hrweb.contoso.com, it's a secure server, it follows all the best practices, so it's not allowing an HTTP-based connection to go, and thus, that's why the app didn't succeed. I'm not going to debug the actual fixing of it, but it's the fact that you wanted to use Fiddler, and you were able to use Fiddler. Now, there was a couple of setup steps that I did before this demo started. Let's take a look at that. So again, I'm going to use the tool called CheckNet Isolation. And we're going to take a look at what is called loopback exempt. So why am I showing you this? I'm showing you this because one of the problems that we had, what we saw, is that there was a lot of attacks that were happening on loopback. And so as far as the Metro-style app is concerned, a Metro-style app cannot do loopback traffic. Now, this does place a problem on developers. It's a burden in terms of, well, I still need to have it working because many times I have my server and client on the same machine. So CheckNet Isolation allows you to fix that. And the way you do that is you use the -a option, and again, -n equal the package family name. And in this case, the package family name was this. Just let's confirm that, BBWE. I go here, look at the package manifest, go right to the bottom. Oh, packaging. And you can see the same thing over here. So I told CheckNet Isolation, please, I'm going to be using this app, and I want you to give it a loopback exemption. And so with that, I was able to get it to work. Now, why is that interesting for Fiddler? Well, Fiddler is acting as a proxy, a man in the middle, so to speak. So the traffic is going down the loopback, and Fiddler is capturing that traffic, and then it's allowing it to go outside. And when it's capturing that traffic, it's able to process that and display it to us. Of course, it's a two-way thing. So that was the first step, which was I added an exemption. The second thing is in Fiddler itself, there's tools, Fiddler options, connections, and I checked this on by, it's off by default, and I checked this. So it was allow remote computers to connect. Why is this necessary? That's because, again, from the operating system's point of view, each of your connected apps is remote to the machine. Because it's remote to the machine, Fiddler it is not aware of this, and so by checking this option, we are able to get it to work. So you don't have to write all this down because I have this in a slide for you. So let's switch back. These are the two things that I just did before the demo started. So now you know how to use Fiddler. So let's look at something else now. When I started debugging, when I started writing applications a long time ago, my favorite way of debugging was like put a bunch of printfs everywhere. Anyone else done that? Yeah, everybody? No? Good. So, well, there's a better way of doing it, and that's using what we call ETW. Event tracing for Windows was, it's not something new for Windows 8, it's existed for some time. And most Windows components use the ETW APIs to write interesting things that are happening in their subcomponent. And so why is this interesting? This is interesting because, remember I said your app, when you debugged on your on your side when you're developing is different than debugging when it's deployed with your client. Well, this allows us to have a elaborate history of whatever happened. So let me show you how that works. And we'll go back to the same sample. And instead of using Fiddler this time, I'm going to use ETW to show you that there is indeed something happening. So let me turn on the event viewer. Okay. I'll maximize this. And in this case, we're going to open up the application and services log. There's a whole bunch of entries underneath that, so we'll just give it a second to catch up. And under Microsoft, there's Windows. I need to do one other thing, which is view analytic and debug logs. That's because we don't do this eventing all the time. Only when you want your particular component to be debugged, do you turn this on. So it's expanded all that. And we're looking for, in this case, runtime networking. Let's see that over here. And this is the runtime networking background transfer. I expand that. I say enable log. Yes. And now let's go back to the app and try that one more time. So start download. Let it do its thing. Hit cancel all. And we'll flip back to the event viewer. I'm going to hit F5. And we see a whole bunch of information over here. So I see this big red bang staring out at me. Obviously some error. Note that this is in time order. So I'm going to go back a few entries over here. And we're going to be looking at the general detail over here. So it says something about background transfer host.exe, whatever that is, it's running. Next, we see that the transfer task instantiation has occurred. You don't have to know what this means, but we're trying to get closer and closer to the error just to see what's happening. So it started processing a work item. Then it started doing begin, started binding. Now it's saying we're getting closer to the red. So it's handle authentication. And now handle response, that means a packet came back, and the next thing we saw was an error. So even though you might not have Fiddler installed on your client's machine, you could just say, hey, go into your app, go into your event viewer, turn this on, do a repro, and export that log and send it to me. I can now take a look at it, and using something like this, you would be able to find out that it is indeed an issue with authentication, so you can fix that. So that's a sample, an example of how you'd use the event viewer. I'd also encourage you, the APIs are open, so if you want, you can take advantage and you can use the exact same thing that Windows components do, and you can, then you don't have to like ship them private binary, etc., to just find out what happened. You can use the same model, and it's very performant, and it's very useful. All right, so let's switch back. All right, so my favorite tool. So when do you use netmon? Sometimes, no matter what you do, you look at logs. Most apps nowadays are like a bunch of layers themselves, and even the networking stack is a whole bunch of layers. But you might not know what to look for, so you want to just capture everything. So that's where netmon is useful. So you can use it to. Netmon is also pretty powerful in the sense that it has a number of packet parsers. It can understand HTTP. It can understand the first thing I worked on when I came to Microsoft was on this routing protocol called OSPF. It understands OSPF and all the packet exchanges there, just as an example. So it's pretty powerful. So let's take a look at that. Switch over. In this case, I'm going to go back to the demo I had earlier, which is VM588B had the server, and it's still listening, so I'm not going to touch that. I'm going to go back here, close solution. Stream project, stream socket. Okay, hit F5. So just before I do that, let me turn on netmon. I'm going to hit the new capture tab, and we're going to hit start over here. So it's now going to trap any traffic that's going out back and forth from the network. So that's why it's saying waiting for network traffic. I'm going to flip back to the actual app and say connect to listener. I have to say VM588B. This time I won't make a typo. I will hit that breakpoint. We'll skip past that. And I'll say go. And at this point, the client was accepted OK, meaning we were able to make a connection to the server. So now what I'm going to do is this one, this number 3 here, send data simulates a hello being sent to the server side. So I'm going to hit that about 3 times. Let's hit that 3 times. And now I'm going to simulate the fact that, hey, this was your app. It was super successful. People are downloading it like crazy, but your server hasn't upgraded the infrastructure. And so in that case, sometimes what happens is your server starts dropping connections. So what I'm going to do for the simulation here is I'm going to go and say close socket. And this is going to cut the connection to the client. Again, remember, this is simulated because I want to show you how powerful netmon is. So I'm going to go back here, flip to netmon. As you can see, there's a whole bunch of traffic that went. So how do I know what's going on? Well, I know that this was a stream socket. So I know that it's TCP. So let's put in TCP in the filter view over here. I'll put TCP, and I can do apply. And you can see, as soon as I did that, it was just the TCP traffic. I can do also, let's say there was many other TCP connections. I can do other things like .port. As you can see, there's a whole bunch of stuff that you could do. But for the purposes here, I'm just going to stick with TCP. Let's take a look at what the exchange is over here. The first is my client is talking to VM588B, so it's sending a SYN, followed by a SYNAC, and followed by an ACK. So this 3-way exchange was when I did the TCP connection to the server. And once these 3 packets go back and forth, that means, OK, we've got our connection, and so we can start sending data. Followed by that, I did 3 hello. I clicked on that button 3 times. You can see that over here, there's an AP. A P stands for push. And if you take a look over here, here's the push function. And if I go on this side, I indeed see that the packet contained hello world in this case. And so and then the client, the server acts back. I send another hello world, ACK, another hello world, and then ACK. And then finally, there's something called a R. Well, what is this thing? It's a reset. This is the simulation where I clicked close, and when I hit close, this is like your server which is under heavy load. It sends a reset back to whatever connections that it's closing down. And this way, I would be able to capture everything on the wire and oh yes, in some cases my app was working, in some cases it's not, and that's because a reset packet's coming back from the server because it's under heavy load, etc. This would be an indication of maybe you need to upgrade your infrastructure. Okay. So let's review. Well, I did 7 or 8 demos. Do you guys have any questions about any one of those demos? Yes, please go ahead. Dump from netmon. You can do so the question was, can you do a dump from netmon? And yes, you can export .cap files, which are capture files. And so you can use that, and you can send that to somebody else. And if they have netmon, by the way, is freely downloadable. I have it in the resources section. So we can take a look at that. Anything else? Yes. Oh, okay. You were talking, so the question was in the Fiddler demo?
No, in the event viewer where you turn on the log,
Right.
there was a series of steps, and then there was just an error. It didn't seem intuitive as to what the error was. You just said, well, obviously it's an authentication.
Right.
And I couldn't see that. Is there a way to translate that error code?
Right. So the question was that in the event viewer, I saw a bunch of events, and I happened to see that there was a. How did I know that it was an authentication? The point here of this demo was that subcomponent in Windows is doing something, and that subcomponent, it could have put any information there it wanted, and it happens to put like. Handling, there was the third last one before the error was like handle authentication, and then it was handle the packet, I think that was the order, and then there was the red bang. So I just made an inference from that as time order went, and it was right bang after that. So there could have been this issue. It's about finding out clues, and that's really what this debugging is about. It's not necessarily, the point is not to find out about each subcomponent and what that subcomponent is giving the error. Let me just finish the review, and I'll be happy to take more questions after that. So we start off this talk by looking at how Windows and Visual Studio combined are giving you rich capabilities of a tool set for helping you debug faster. We also looked at a number of tools that you already knew, for example, Fiddler. So you could continue to debug. And Fiddler in particular had a couple of issues. I also showed you Netmon, and Netmon is very powerful. I suggest that you take it, download it, play with it. There's other similar tools that are there in the market, also freeware, but this one also gives you a lot of capabilities, so it's pretty exceptional. So a couple of related sessions. Both of these have already happened. The first one is about, please take a look at the video or the slide decks for either of them. The first one's about what a good Metro app does. And there's a good amount of detail about doing 3G, 4G, how to handle that. When do you handle, like, I disconnected from one access point and then I connected over another access point. So there's different things that we talk about there. It's an event-driven model. We've, again, tried to do as much heavy lifting as possible. The second talk here is the one that happened earlier this afternoon, and that's about what are all the set of APIs that we're providing. There's new APIs and there are new classes. Each of these classes is giving you a lot of information. So you can write one line of code where you had to write previously 10,000 lines of code, for example. Maybe you had to write 100,000, not 100,000, but like hundreds of lines of code, shrinking to just 1 or 2 lines of code. So with that, this slide talks about various other. The first 4 about like goodness. So please read them. And the last 2 are how to download Fiddler as well as Netmon. And with that, I'm ready to take Q&A for the next few minutes. Please, could you come to the mic, please?
The tool was called Check Net Isolation.
That's right.
Can that tool be launched from the Visual Studio debugger and put the output to the console out in Visual Studio? Kind of automatically, or you went into the command line on the console?
One thing I did not point out as I was going through the demo steps was the fact that I ran that in an elevated command prompt. That's because you need special privileges to do that kind of operation. So I have previously wired Visual Studio to launch like command prompts. Like you can suck the output from that, but we should really talk to a Visual Studio expert to see how you could do that. So, and I can help you find somebody downstairs in the.
Just curious.
Yeah. So I do not know the answer. So that's the correct answer. Yes.
I have a Windows service that hosts a WCF service.
Okay.
And I want to build a WinRT client that can communicate with that WCF service. And I was told that that wasn't possible, and it seemed with your Fiddler demo that having to put an exception in to allow for that local communication to occur kind of underscores that. Is that true, or is there some other mechanism that I can collect data out of my Windows service and publish it to a WinRT client?
Right. So if you're asking that I'm trying to debug, and only when I'm trying to debug can I use this exception, then yes, the answer is yes. But otherwise, as I was saying before, that really it's about isolating the app from the networking point of view. So that's why I check net isolation. You're not allowed to do that kind of operation.
So there's no way to develop that kind of application?
Which is talking on like the loopback interface?
Right. So for example, I've got a local device that the Windows service is collecting data from, and I need to publish that to that local client and possibly a remote client.
Okay.
So in that use case, WRT fails me. Is that correct?
Sorry, what was the last part you said?
WinRT fails me because I can't produce that local client that communicates with that local service.
So maybe we need to stand on a whiteboard and probably I need to understand that a little bit. I will be available at the Ask the Experts later on, so maybe we can meet offline and talk. Thanks. Another question from this side? Okay, still on that side.
Hi, in your last demo, you showed the reset packet coming across when you close the server. Can the client detect that and take some action?
Oh, okay. So I think from the perspective of the client, the connection that it had really got terminated, right? So if you try to do the next operation on it, normally it'll return an error for you saying that, sorry, invalid handle or something like that. So it really depends on the API that you're referring to. And so the fact that it was the reset, the R bit being set in the, that's, I think, usually we abstract the apps away from that much of information.
Okay, so you'd have to do another read or write to find out.
Yeah, you were saying that you would have to do a read or write. So it would be the next operation, whatever that next operation would be, depending on it was a stream WebSocket or just a regular stream socket, whatever it is that you were trying to do. Okay. Another question?
Hi, I have a question.
Yes,
Sorry.
please go ahead.
I was just wondering, let's say that you have a client that's running on a Windows phone.
Okay.
And then you have like a client server guy, I'm thinking WebSocket
Okay.
communication. And you can debug on your client server guy, but can you capture the data from the client on the phone in any simple way?
Are you asking about how you debug on the client side, in this case the phone client?
Yeah, or at least get the information from it.
Right. So as I was showing you earlier, Netmon at least can capture all that information going back and forth.
Yeah, to and forth.
To and fro.
Yeah.
I am not an expert on the Windows Phone, but I do know that downstairs in the booth there's like a phone section. So maybe we can ask them, and they might be able to tell us about the rich. I know that they also have a great tool set, and Visual Studio also helps us, but I'm not the expert there.
Okay, thank you.
Sure. Any other question? All right, thank you. Thank you all for coming here.